Hello and welcome to WNIE Radio, kindly sponsored by Pace, Insituair, Humiseal, Cyber Optics, Juki, ART, Co-Young and Electrolube.
Hello, I'm Chloe O'Brien with What's New in Electronics. I'm here today with Tim Burke from Arch Systems. Tim, how are you today?
Good, how are you doing?
Yes, very well, thank you. There's lots of things that we want to talk about today, and I just want to start with where exactly you serve the manufacturing industry. Who else is doing machine data mining and looking for untapped utilization?
Yeah, no, it's a great question. And I think the first thing to point out is this is a very new area of technology. It's only been fairly recently that both the machine data as well as the sort of algorithms technology that know how to deal with those large amounts of data have been together in the same place. So there aren't direct analogs to doing what we're doing sort of on machine data in the factory. The closest analogs are machine learning or AI companies that have had a lot of success sort of mining either supply chain data, so trying to understand what parts are coming into the factory, if they're going to be delayed. There's some companies having great success there, as well as companies that are looking at the ERP or sort of higher levels of process in the organization and trying to find, for example, optimizations in accounts payable or other business processes. But what we're doing is sort of different because we're working on these large data sets from machines. And it's an area that hasn't yet been explored because it's been very challenging to sort of get all that data into the right place up till now. So you can apply the same techniques that have worked so well in other areas of the enterprise.
Where do you see the role of industry standards in this then? Won't standards eventually solve the data collection problem?
So yeah, it's an important point. I guess the first thing I would say is standards are very important. For example, we at Arch, myself personally, so I sit on the IPC CFX leadership committee, and we want to advance standards as much as possible because they make everyone's life easier. They make our life easier collecting data, as you said, but they also make it easier for factories to have machines talk to each other, talk to the MES, talk to other factory systems, of which, now in a modern factory, there are dozens of systems that want machine data, and having a common standard or language for those systems to talk to each other just reduces duplicate work. So that's true. One of the challenges, though, is that oftentimes standards are written for communicating very small amounts of data for a focused known purpose. So for example, just tell me when you finish processing a part. That's all I need to know because my current system today only deals with one small aspect of machine data. One of the challenges, or one of the areas where we see standards not necessarily always solving the problem, is that we need to collect data that doesn't necessarily have a known use in the factory yet, because the whole point of process mining is that we discover what the use is. So we often find ourselves having to augment the data that's currently available in standards, because the standard by definition contains everything that's standard, what we know there's an important use case for in the factory today. And so that's very important. And over time, that set of things will grow. But for now, we can collect that standard data, but we also then collect additional data on the side that the factory didn't know was valuable yet, but we're able to find significant value in it and then use that information to guide the standard and say, actually, if you add this extra data field that you're collecting, here's all of what it could open up, which we didn't know about before. So we see it as, yes, it's very important. Standards reduce work for everyone, but oftentimes the kind of data that process mining needs is the kind of data that no one thought was really important to collect en masse before. So it's not in the standard yet. And so we work together to make sure that we put it in the standard so that it becomes easier to collect in the future. But today we have to find other ways to collect it.
Of course. And I know that you've mentioned that the machines speak different languages. Do you have anything additional you can say on that?
Sure. So one thing to keep in mind is that machines live for a very long time in these factories. We routinely work with machines that are 20, 25 years old. And so if you think about a standard that is 5 years old, you may have only 25%, maybe less, 10, 15% of machines in the factory might speak that standard, even if the standard has broad adoption today. What we find is that there are, in a given factory, always many different standards or languages or even vendor proprietary communication protocols in play. And that's just the reality of what a modern factory is. Standards are great in that they reduce that number from, say, 15 to 10 or 7, but rarely is it one, where there's sort of one standard that all machines speak and they all speak it perfectly and it contains all of their data. So it's just sort of a reality of how modern factories work, given that machines have such a long industrial lifetime, that a lot of the machines we deal with were built a decade before the current standards were written down.
Okay, I see. They don't like to make it easy for you then, no?
No, yeah. Well, that's why we have a job.
Exactly. Just you could also let us know, what's the difference between an MES running a factory and what you would call process mining or process modeling?
Yes, this is a very important question, because since what we do and what the MES does both sit sort of above the machine layer. So think of in a factory, you have a bunch of machines, but then the machines are connected together trying to build a product. So we call that the process layer. What is the goal of having these machines run different steps on the same product? Like, what are you trying to achieve in the factory with these machines? So the MES's job is to sort of ensure that the factory performs what it's supposed to do. It's supposed to run the factory. So it says, I get a work order come in. That means I use machine A, B, and C in this order. And then I just want to collect very basic information that machine A did its job, machine B did its job, machine C did its job. And it's sort of focused on, one, running the factory, but two, collecting just the bare minimum information that it needs to do its job so it doesn't get overwhelmed, because it has to make sort of real-time decisions. So that's the one. MES is about control and about small amounts of data to make sort of fixed real-time decisions in order to make the factory run day to day. So if you look on our side, it's actually completely the opposite. So we're not focused on how to make the factory run day to day in the nitty gritty, but more just sort of observing what's going on. So assuming you have an MES installed, assuming the MES is running perfectly, your factory is producing products, we just want to collect as much data as possible on how those products are being built, and then look at it over a long period of time and compare thousands of instances of the same product. And what we found is that by doing that, we can often find very key areas where we can suggest improvements that weren't obvious when you're focused down on the nitty gritty of like this product, that product, this instance. So for example, we'll collect data on thousands of instances of a given product being built. And then by comparing them all to each other and using these advanced ML AI algorithms, we can actually figure out that this single product could have been built 20 to 40% faster. And we can find that for many products. So when you put all that together, it's sort of a new class of factory optimization system, which sits at the same level as the MES in terms of it works on processes on top of machine data, but rather than focused on real-time day-to-day control, is focused on just passively collecting as much information as possible about how things are going, and then feeding it into the advanced algorithms we have available to us now in the cloud to then figure out, if you were to focus in on where to make things better, what's your best opportunity? And as I was saying, we often find 20 to 40% gains, sort of relative gains in productivity that could be had with the exact same processes, machines, no major disruptive changes to the factory, just understanding where the key bottlenecks are based on sifting through these vast amounts of data.
Oh, wow. So utilization of 20 to 40% increasing. Do you have a figure of how much value that can actually add? Is there a monetary figure for that?
Yeah, so there is. So 20 to 40% improvement gains for large manufacturers, especially ones which have, large numbers of these expensive machines, especially sort of pick and place machines in the SMT industry. 20 to 40% relative improvement gains can be sort of $50 to $100 million in savings, both in asset depreciation as well as increased productivity in the factory. Wow. So very significant numbers.
Yeah, massive numbers. And especially, like you said, for those large manufacturers, without many changes, you can make that much more. It's incredible. And one more thing I am curious about, your customers. I imagine it's quite exciting for you and for them right now to be getting in there and finding these kinds of numbers.
Yeah, of course. So for example, right now we're installed in 4 of the top 10 contract manufacturers in the EMS industry. And while some of our engagements, we can't talk about publicly who they are, one that we can talk about because they were sort of a very early believer in the ability of this kind of analysis is Flex. So Flex is one of our large reference customers. We work very closely with them. And with Flex, we're deploying our technology in all of their factories worldwide on all of their SMT machines to find these kinds of efficiency gains and enable just new kinds of use cases that weren't possible before you started collecting this large amount of data and feeding it into these algorithms.
That's amazing. Thank you very much. And we are very excited to see what Arch Systems bring out next, talk about next. So thank you for joining me today, and I look forward to speaking to you soon.
Yeah, thank you very much, Chloe.
Thank you.
From all of us at What's New in Electronics, stay safe, stay well, and we look forward to seeing you soon.